if you have a super stiff bike and after 30 minutes your body's wrecked, then you're not actually getting any faster. Whereas a bike that's more forgiving, you could ride for 8 hours in a Tour de France and the next day you're fine. So it's like if you're doing a like a Tour de France or a Giro d'Italia and you're doing multiple weeks, what bike gets you the fastest speed without completely breaking you down is important.
Okay. Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lin. Practical AI is brought to you by Pocket AI.
Pocket AI is a visualization tool that allows you to prune your models without any loss in accuracy. Visualizing your model weights is like a brain surgeon being able to find individual neurons and removing them without harm to the brain. Similarly, Pocket AI allows you to analyze and prune the weights in your model. Using Pocket AI, we have proven we can select the right backbone model, get that model to actually work, make that model more stable, increase a model's accuracy, decrease the size of a model by up to 60%, and put smaller models into production for half the cost. Finally, you can be done with endless brute force training and new model trials. Pocket AI allows you to perform brain surgery on your existing models, making them not only smaller, but better.
Peter, today we wanted to talk about Apple's breakthroughs or announcements. First, before we do that, I wanted to hit one of the conundrums out there, and that is AI-generated code. So tell us a little bit about what is going on with AI-generated code and if it's any good.
Yeah, so now we're seeing people talk about tech debt of AI generated code because if you get bad code, it doesn't run, so then you don't run it. But there's this category of code that looks like it's good, but it's actually not great code, and it slips through your code review. And what happens is that code then creates this depth of like, well, no one knows what it really is doing, and there's probably too much code. And then it takes you 10 times longer to read the code and figure out why it's bad.
So I mean, this is a very, very basic concept, but you would think that if I can get halfway with the code, I'm 50% farther along, but just the opposite might be true.
Yeah, I mean, it works great if you are the one writing it and you don't have to maintain it. You don't have to support it. You don't have to fix it. You don't have to be on the pager. You don't have to get Teams calls at 2 a.m. It's great, right? Because it's code you write and you throw over a wall and you forget about it. But if you're a serious engineer and you're doing DevOps, then you care.
Yeah. Well, okay. So let's take the serious engineer out of this, and I'm going to ask you a question you might not be prepared for. But as a business, how do you figure out when you kind of cross that threshold of I'm creating a more tech debt than I'm eliminating?
Well, the great way that Amazon found out was you deploy code and it crashed the system for a few days. That's how.
Okay.
That's how you know, and they hire people back.
All right. So it might be one of those.
That's a real
things.
answer. Yeah.
Fair enough. Okay. Let's move on to our next topic. The next one is we've got Karpathy kind of came out with something that is about research. Tell us a little bit about Karpathy and research and what was sort of announced this week.
Yeah. So he released a new Git repo. It's a framework that he wrote to do auto research. And the idea is you can automate the research using agents, which it's not new, obviously, because people have been doing this. A few years back, Google created models to generate AI models. So this is a kind of been going on for a few years now. So he released a framework that's supposed to help you do research.
And it was talked about a lot. What's the impact? Like, why does this matter?
Well, in theory, it's supposed to make a researcher superpower because now you don't have to do a lot of the grunt work. You can tell an agent to do a lot of the work for you.
Okay. And obviously we can see some benefits of agentic research. You could have stuff happening all the time. We've talked about this use case for a long time of finding new compounds and materials, and you could theoretically have an AI do that, and then maybe even have a robot test them, or a series of robots or whatever. Is there a limit to what can happen in sort of the AI research space where this is it's going to hit a wall, or this just isn't that cool, or is this really, really profound?
I think it's both. It could be profound, but it is there's also limits, because even if you can come up with new and novel compounds that could be useful, you still have to know how to manufacture that at scale. And that's not something you can simulate, because the real world is not a clinging computer simulation.
Yeah, and simulation is another thing. I mean, you have to, in research, you test your research, your hypotheses, right? And research isn't necessarily the simulating part either, because then you have to test your simulations as well, right?
Yeah. Well, like, take, for example, in cycling, the thing that has happened in the last few years is they run computer models to figure out what's the best way to lay up carbon fibers so you get the best attributes for your bike frame. But then the day after you've narrowed it down to like 20, you have to build those frames and then actually test it in a real rig, right? And then you have to see, okay, well, it came up with this crazy layup, but if I'm telling a human being to lay up this complex series of unidirectional fibers, is it going to increase the time it takes to make the frame by 10 times? Because if it is, then you can't use it, because you can't make enough frames fast enough.
And while I can't think of an example, there's also scenarios where humans just don't like the best version of something either, right? Where they
Well, that's true in cycling. Like, for many years, one of the big name manufacturers had super stiff bikes, right? Because in theory, the stiff the bike, the more efficient it is with transferring your foot pressure to the road. But the problem is, it's really uncomfortable, and it's not. It's great only in theory, but on your butt and on your hands and your back, it's terrible.
Got it. So basically, in that case, a cyclist would put up with some level of less than great because there's a other the trade-offs are too high, essentially.
Right, because if you have a super stiff bike and after 30 minutes your body's wrecked, then you're not actually getting any faster. Whereas a bike that's more forgiving, you can ride for 8 hours in a Tour de France, and the next day you're fine. So it's like if you're doing this, like a Tour de France or a Giro d'Italia, and you're doing multiple weeks, what bike gets you the fastest speed without completely breaking you down is important.
Okay, good. All right, so research is advancing. Now let's talk about Apple. What's Apple come up with this week? This is sort of our main topic today. So what did we learn from Apple?
The big thing is the new M5 chip. They've broken up the CPU and the GPU, because in the previous versions, the whole entire die had the CPU and GPU all together. The new version, the CPU cluster is one, the GPU is separate, and they use their fusion to fuse it together, which means they can mix and match GPU clusters and GPU clusters. And the other new thing is the GPU, the new version of the GPU actually is faster, and it has built into it the NPU, which is kind of like NVIDIA's tensor cores.
Okay, so let's just get people up to speed on CPUs versus GPUs versus NPUs. And I think the best way to start with this is not only what does it do, but what purpose was it originally trying to solve? So start with a CPU.
Yeah. So CPU is meant to do like a single instruction or single thing. Like when you run Word, like it's running Word. And it might in the background occasionally run other things. All right. So a CPU, typically there's like 5, 4, 10 cores, and each core can run like 2 processes, which are called threads. So you can't do a lot of things massively in parallel. GPUs were designed to process pixels. So if you have a MacBook and it's a, nice high-res screen, it's processing all those pixels individually. And so it's doing thousands upon thousands of pixels in parallel. So it's very different than a CPU, because it's fundamentally doing lots of things, same operation, basically each pixel on the screen, and it's doing it in parallel. NPU is built to do machine learning stuff, basically matrix math, very quickly and efficiently. So that's the three different kinds.
Okay, and the way I look at it, this is that GPU was basically NVIDIA's thing. They're processing pixels for graphics for games, right? And machine learning comes around. All of a sudden, NVIDIA has sort of this side purpose, which becomes its main purpose, and that is processing all this math in parallel. But its primary objective was to process pixels for graphics. So the NPU, which I think is what neural processing unit, right?
Yep.
It comes along and it basically says the GPU is almost properly situated to handle the machine learning that we need to process, but it's not perfect. So we're going to basically deliver that, and we're going to use GPUs inside our neural processing units when we need to. But for the most part, NPUs are specifically designed for that purpose. Is that accurate?
Yep. Yeah, they're designed for machine learning workloads.
Okay. So now tell us again, just because I think now that we have the context, what did Apple do with their processing units and why is it important?
So Apple added the NPU into the GPUs. So same thing with the NVIDIA. NVIDIA added the tensor cores into their GPUs. So it's same thing.
Okay. And they separated that from the CPU?
So now the GPUs can do really efficiently the machine learning stuff, basically.
Okay. And let's say I got an Apple laptop and I've got one of these sort of M5 configuration. Can I expand it? Can I grow it? Can I add to it, subtract it?
Well, so you can't, but in theory, it gives Apple the flexibility to mix and match CPU and GPU so that if you want with triple number of GPUs, they could easily do that.
Okay. So it's not like RAM where I can just go get that and add that to my hard drive right now, but at some point that might be an option.
It's an option for Apple, but not for you and me. So it gives Apple the option of creating bigger and better Mac Studios with like 4 times the GPUs.
I'm assuming that at some point one of those little minis is going to come out that's got the ability to do something like that, right? Where it's going to have probably 4 or 5 NPUs and 1 CPU.
So right now the regular M processors have like 20 or 16 NPUs already.
Oh, they do. Okay, so they're already just massive.
Yeah, they already have them. But now the GPUs also can do that because it's got one in it.
Okay, cool. And so, is this worth investing in? And how much would it cost me to get one?
Really, I think that, so the roadmap is Apple is going to become the hardware for anything that needs to use AI.
So while Apple's been sitting behind the scenes, not building models or at least not having foundational models, they've essentially fallen back on their strength, and that is they're a hardware company.
That their hardware is just perfectly positioned to do all this stuff. Now, unfortunately, their software team hasn't been able to keep up and deliver, but the hardware is there. So
okay. And M5 Pro, how much does that cost? Any idea?
I haven't looked, but I mean, it's way cheaper than an H100 for sure.
I mean, $3,000,
H100 was still H100. Well, the H100's been discontinued now, I think, because the Broadwell chips are new now. So it used to be $20K for H100 with, what was it, 40 gigs of memory, and the 96 gig version was $40K. So that's way more expensive than a Mac Studio.
Well, maybe not. I don't know. Maybe a Mac Studio is $20,000.
I think a Mac Studio fully loaded was only about $15,000.
Okay. Okay.
with more memory.
All right. Okay.
512 versus 96. So, that's quite a bit.
Yeah. Good. All right. Well, good topic. Thanks, Peter. Thanks for teaching us some details on this stuff. And it's fun to see Apple kind of come alive last couple of weeks. We've just been talking about Apple a little bit more after about 2 years of nothing. So
yeah,
good. We will post all the links in the YouTube, and we will also post this entire video up on Spotify if you prefer to watch us there. We'll catch you next time. Thanks, everybody.